Hey guys, welcome to Pre-Algebra Chapter 11, where we are now going to be talking about data analysis and probability. So as we get into this chapter, this is some of the stuff you can look forward to. Like I said, we'll be talking about data analysis first, so bar graphs and histograms and such, and then we'll get into box and whisker plots. Today we'll be talking about stem and leaf plots as well. And then we'll get into probability, right, and the probability of some event and another event, or the probability of some event or another event. What's the probability of rolling, a 1 and a 5? Or what's the probability of rolling a 2 or a 3? Okay, very distinct and different things. So that's what we'll be getting into. So as I said, today in 11.1, we're going to be talking about stem and leaf plots, histograms, and we'll also talk about frequency tables. So, stem and leaf plot. Well, what does a stem and leaf plot do? Well, it's one way of showing some data, and no, we're not going to be drawing trees, we'll be drawing things that look a little more like that. And we call them stem and leaf plots because they do share something in common with a real stem and a leaf, in that we have a column called the stem, and then we have leaves that branch off and give us the final piece of data for individual frequencies so that we can interpret information. So let's go ahead and get into one. Alright, so we're going to do a problem that's based on some track information. So the distance in centimeters of 11 jumps, okay, from the final round of a women's long jump competition are listed right there. And what we're going to do is we're going to use a stem and leaf plot to display this data, and then we'll be able to interpret some of that data once it's displayed. So these are the 11 values that we're going to be working with. But before we make our own stem and leaf plot, we need to remember a couple things. We need to keep it ordered, right? Order in the court, Judge Judy. And we need to make a key, all right? So those two things are incredibly important. So let's go ahead and make our stem and leaf plot. All right, so here we go. I pulled over the distances that are, again, in centimeters from that long jump competition. Okay, again, 11 pieces of data. So the first thing we're going to do is title it, okay? And this was from a women's long jump competition, so let's just call it women's long jump. Okay, and now what we're going to do is go ahead and draw our line. Okay, it's going to split right down the middle. Okay, and over here we're going to have stems, or our stem, and then over here we're going to have our leaves. Okay. All right, so our stems. What is our stem going to be? All right, and that's when we need to go first look at our data. All right, and what we want to do is in our leaves, we only want to have one digit here. Okay, one digit there, and over here we might have one digit, or we might have two digits. Okay, so an example of that might be, hey, how about we do? Let's say we needed to put into a stem and leaf plot the number 51. Okay, so I put a 5 here and a 1 there. All right, now I'd have to make a key to make sure we know that's 51, and we'll get into that in a second. But if you want to graph 524, well, over here I do 5, 2, and then the one digit over there, the last one would be 4, and we put him there. So the leaves, you only want to have one digit per piece of data that you're going to be graphing over there. So I'm going to erase those real quick. You can obviously keep them on your paper. So let's get over here. So I'm going to look at my data and ask myself, okay, what are the stems I'm going to need? Well, again, it's going to be every single value, okay, except every single digit except the last digit, okay, is going to form a stem. So, for example, this first number of 669, the 66 is going to be a stem, okay? The 70 is going to be a stem, but the 2 will be a leaf. The 64 there will be a stem, but the 4 will be a leaf, and so on and so forth, okay? So first what I'm going to do, before I even put them in my table, is I'm going to, again, we need to keep them ordered, right? So I'm actually going to write these out in order. All right, so I've gone ahead and ordered them, and I'm going to figure out, okay, what's the smallest stem I'm going to need, and what's the largest stem? Well, again, let's look at this. Okay, if this is an order going this way, then up there, and then up there, then this would be my smallest piece of data, okay, 644, and then my largest is 702. So my smallest stem is going to be a 64. My largest stem will be a 70. All right, so I'm going to go ahead and start with the 64. And I know I'm going to have to go all the way down to 70, okay? And you'll see why that's important here in a second. Just keeping that in mind. So I'm going to go ahead and graph the first piece of data. It's 6, 4, 4. So again, my 6 and my first 4 go there. My last digit, which is a 4, goes there. And then I ask myself, okay, are there any more 6 4s? No. Well, no, there's no more 6 4s. So the next, I'm going to cross it out. And the next thing I would go to is 6 6. But when it comes to a stem and leaf plot, if you look at this number, I interpret it as like 64, okay, even though it's 640, okay. The next thing I would go to is 6 6, but between 6 4 and 6 6, there was actually a 6 5. So I'm going to write that 6 5. I'm going to leave it. Okay, and what that tells me is that, wait, there's no 6 5s up here, and that's true. It's that we don't have any 650 centimeters anywhere between 650 and 659 values. And that's important because we want to see the gaps in our table, and that'll become a little more prominent later on. So let's move to 6 6 2. My stem will be 6 6. My leaf will be 2. Then I have a 6 6 9. So instead of writing another 6 6, I keep this 6 6, and then ways away from that 2, I'm going to write a 9. So this is 662, 662. This is 669. Okay. After 6 6 would come 6 7. Okay, I do have a 6 7, and it's a 6 7 0. So I just write the 0. I have another 6 7. It's a 6 7 3. Another one 6 7 6. Okay, and that's it for 6 7. After 6 7 is going to come 6 8. And I'm going to have to kind of cross this one out for right now because we're going to need more room. Oh, come on. Sorry, guys. Cross that 70 out. We'll be back to... We'll have to get him further down. Okay, anyway, I'm sorry. So we're on 6 8. So 6 8 4. And you're kind of getting the idea, so I'll just finish this up real quick. All right, cool. So we are almost done. I've used up all my other values I had left in my table, and if you finish this, which you should have, it should look exactly like this. Okay. So what can we interpret, and what's the one thing we need to do yet? Well, we kept it in order, right? Everything goes in numerical order, but right now we have a couple things that this table could actually stand for, which is why we need to make our key. All right, we need to make our key. Currently, this table could read 660, like this value right here could be 664, which we know it is. But without a key, it could mean, well, 64.4. Okay? And without a key, we don't know, right? Maybe this is stands for the tens and ones, and then the leaves is the tenths decimal place. We know it's not, but someone reading our stem and leaf plot might not. So we need to make a key. All right, so our key is going to be down at the bottom, and you want to write key, colon. Okay, so people know, okay, all right, here's the key, and what does it mean? Well, the key is going to be 64, and then we're going to draw like a little piece of the line right there, 4 equals 644 centimeters. So when they read that, they know this does not mean 64.4. This does not mean 67.0. This means 644 centimeters, right? So there's your key. All right, so now let's interpret some of these stem and leaf plots. Really, it's kind of the point of making them so we can, interpret the data. So the stem and leaf plot here shows the prices in dollars of pairs of sneakers at two different shoe stores, so A and B. And what can we conclude? Well, first of all, let's look at the key. Okay, 30 means actually $30. It doesn't mean 30 cents, okay, or anything like that. So 30 bucks. So we have a pair of shoes here. It's $30. We have another one, 32. That and that right there would mean a $69 pair of shoes, so on and so forth. Okay, so what can we tell? Well, the cool thing about stem and leaves is that they actually help us tell the median really quick. And if you remember from mean, median, mode, median is the middle of the road. So if I had 1, 7, 9, 12, 15, the middle piece of data would be the 9. Okay, so let's count the data up here at store A. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, so I'm going to cross out 1 at the front and 1 at the back and keep going till I am done. Almost there. Right there. Okay, so that leaf is what was left, and what was his stem? Would be 4. So store A has a median price of $49. Okay, that's very helpful. So why don't you take a second? I want you to find store B's median. Go ahead, pause the video, find the median price for store B, and then play it when you're done. All right, cool. So I hope you found that the median at store B was $43. Okay, and this is another reason we need to have these stem and leaf plots ordered, because if we don't have them ordered, our medians aren't going to work out, or we'll have to reorder them. Okay, so it's better just to do it up front. All right, so now I want you to pause the video and I want you to answer these 3 questions. Okay, so go ahead, pause it, use the stem and leaf plot, and then see what you get. All right, so who has more shoe prices under $50? All right, well, I can look here and say, here's where $50 starts at store A. Okay, so there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Store A has 10 under $50. So 10 under $50. Store B, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So store B has 13 under $50. So we actually know that store B has more under $50. And then who has more even distribution of prices? Well, so the distribution of prices basically means, how many are in the $30 range, $40 range, $50, so on and so forth, and who has more even distribution? Well, I would say store A probably does, because he's got 5 in the $30 to $39 category. He's got 5 in the $40 to $41, okay, so on and so forth. And one of the other cool things about looking at the distribution is that, well, if it looks like an even amount, okay, like this looks like, oh man, if there's one more piece of data there, it would be perfectly like rectangular, right? Like actually like what it would look like as a shape, then it's actually going to be pretty even, right? Here, if we look at store B, we have kind of an odd shape, right? If we did one of these, like almost like a bar graph, right? We don't have something that looks incredibly even. So actually store A has a more even distribution, okay? And then I just kind of was leaving it up to you guys on this third question about what is another thing you can conclude from store B. Okay, I look at it and I go, well, you know what? More than like half the sneakers at store B fall into these 2 categories right there. All right. So in fact, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 pairs of shoes from $30 to $49. 49. And then we only have 1, 2, 3, 4, 5, 6, 7 pairs of shoes from $50 to $69. So, you could probably pull out a couple more things, but that's what I found. All right, so next we'll talk about frequency tables. And frequency tables are really just another way to display data that falls within certain intervals. Okay, so we'll use this problem here. In the United States, hurricane season starts June 1st and lasts about 26 weeks. So meteorologists record the number of weeks into the season each hurricane occurs. So this first piece of data, 6 here. That means there was a hurricane that occurred 6 weeks into the season. Okay. Now the number of weeks the hurricane into which a hurricane season in which the Atlantic hurricanes occurred from 1997 to 2000 are listed here. So this is data not just of 1 year, but 97, 98, 99, and 2000. So 4 different years. So 6 weeks into the hurricane season, somewhere between 1997 and 2000, a hurricane occurred. 7 weeks in, a hurricane occurred. 16 weeks in, again, another hurricane occurred. Okay, 2 hurricanes occurred 17 weeks into the season down there. Oh, but then we have some more 17s down there. Okay, so what we're going to do is we're going to make a frequency table to show us like how frequently certain hurricanes come about and how many weeks into the season that happens, to see if we can see a trend. So the first thing we're going to do is choose intervals of equal size. Okay, so what do I mean by choose intervals of equal size? Well, let's say this. If I had intervals that we're going to use of 1 week, okay, so that would mean our frequency table would look like this. Okay, the first column would be weeks into the season. And so 1 week into the season, 2 weeks into the season, 3 weeks into the season, 4. They're intervals of 1 week. Problem is, if we did that, though, well, we'd have to have, so let's see, 6 weeks into the season, 7, then 8, was there an 8? No, and then 9, no, is there a 10? Yeah, there's a 10. So we'd actually have a really, really long table because we'd have to account for all the weeks that are present. So instead of that, let's do this. Let's choose interval of 2 weeks, okay? And what I mean by that is we're going to go from, well, 0 weeks to 2 weeks into the season. Are there any 0s, 1s, or 2s here? No. Okay, so we'll skip those. Any 3 to, 3 to 5? No. Any 6 to 8? Yeah, there's a 6 to 8 there. Okay, so what we're going to do is we're going to start there. And what it does is it just makes our table a little smaller. Okay, so I'm going to start to set up our table. It's going to look like this. All right, so here we go. I'm starting to set up our table. We're going to choose intervals of equal size of 2 weeks. And we don't have any hurricanes that occurred 0, 1, 2, 3, 4, or 5 weeks into the season, so I don't even have to account for those. I'm just going to find the smallest piece of data, which was a 6. Okay, and we're doing 2 intervals of 2 weeks, so weeks into season, my first thing is going to be 6 to 8. Okay, so from 6 to 8 weeks into the season, do we have any hurricanes that have occurred in those years from 1997 to 2000? Well, there's a 6 right there. Okay, so in the tally column, what I'm going to do is I'm going to just mark a little 1. Okay, now let's keep looking for anything between 6 and 8. So there's a 7. We have another. Awesome. Okay, keep looking, keep looking. All right, there's nothing else. Okay, so then what we're going to do in the frequency column, I'm going to ask, how many tallies do I have? 2. So 6 to 8 weeks into the season, between 1997 and 2000, how many hurricanes occurred? 2. All right, and then we're just going to fill in the rest of the table. So after 6 to 8, we would choose the next interval of 2, so 9 to 11. All right, now how many hurricanes occurred 9 to 11 weeks in? Gonna look. Any 9 to 11? Right there, 10. So we already accounted for 6 and 7. Now we've accounted for 10. Okay, 10 weeks into the season, there was a hurricane that occurred. So 1. Okay, now there's nothing else between 9 and 11, so my frequency is also 1. All right. So why don't you guys fill in the rest, pause the video, okay? And again, I might check this in your notes, so it might be beneficial to actually do this. All right, and fill in the rest. So the next interval would be 13 to 15, and then so on and so forth. So pause the video, try that, and play it when you're done. All right, so I'll fill in the rest and then just kind of snap to all of it. So for 12 to 14 weeks, I counted 1, 2, 3, 4, 5, 6, 7, 8 times a hurricane occurred 12 to 14 weeks into the season, and so I put an 8 there. Okay, so the rest of your table should look like this. All right, so constructing the table, all right, is super important. But what's maybe even more important than constructing it correctly is that we actually learn to interpret what we see. Okay, so let's just kind of look at this and do some interpretation. If we were just given this table and we didn't even make it ourselves, we'd have to look at this and go, all right, well, what can we tell? Well, 6 to 8 weeks into the season, there was only 2 hurricanes recorded between 1997 to 2000. Okay, so that's not a lot. 9 to 11 weeks into the season, there was even less. But when you get to 12 to 14 weeks, 15 to 17, and even 18 to 20, not as much as these 2, that's when you start to see it, right? So if hurricane season starts June 1st, and it said it goes about 26 weeks, well, then, man, 6 to 8 weeks in, we really can't even expect that much. So that means if it starts June 1st, 6 weeks after June 1st is like the middle of July, more or less. All right, so even in the middle of July, we're in hurricane season, but we shouldn't really expect to see too many. However, 12 to 14 weeks in there, so 12 weeks is approximately 3 months, so June, July, August, September. When we get into September, we're going to start looking out for some hurricanes, okay? All right, so as quickly as I can, because I know we're getting a little long, is histograms, okay? We're going to talk about histograms. So histograms look a lot like bar graphs, but they're not, and we'll talk about why. But histograms display data from a frequency table. So I copied and pasted in our frequency table from the hurricane problem. Okay, and what we're going to notice is there's no space in between the bars, right? So a bar graph would maybe look like this. We'll do chocolate and vanilla, and we'll, I guess, do 1, 2, 3. So you take a poll of your friends, right? 2 of them prefer chocolate, and 3 of them prefer vanilla, and maybe other. Okay, and 1 of them prefers something else. So that would be a bar graph, right? However, histograms are different, and I know that's not perfect, but bear with me. Histograms, there's no space in between, okay, and it displays information from a frequency table, and it's for continuous data, okay. This is not continuous data down here. Chocolate, vanilla, other, okay. When we use a histogram, we're going to be talking about most often time, okay. So this is a bar graph, but we're going to construct a histogram. Okay, now the x-axis, or the left to right, which would be chocolate, vanilla here, except this is a bar graph. So this down here would be the type of ice cream. In a histogram, this x-axis represents the type of frequency. So are we talking about, space of time of 1 to 5 minutes, or 2 to 3 years, or 6 to 8 weeks, right? 9 to 11 weeks. And the y-axis, the up and down, is going to represent the frequency. How many times did a hurricane occur 6 to 8 weeks into the season, right? Well, it'd be 2. The frequency there from our table was 2. So let's go ahead and construct that really quickly. All right, so when we construct it, the first thing I need to know is, well, the x-axis, the left to right, represents a type of frequency. So I'm going to go down here and go, okay, well, my frequencies are like numbers, but what's the type? Well, it's weeks into the season, and I have 6 to 8, 9 to 11, 12 to 14, so on and so forth. So when I come down here, this is what I'm going to do. All right, my first type was 6 to 8 weeks, so I'm going to write 6 to 8, okay? And now my label down here is going to be weeks into hurricane season. Like that, okay? And then after 6 to 8, well, we would have 9 to 11. Okay, so then we write 9 to 11. And then after that would come the 12 to 14, and so on and so forth until you get this. All right, so it should look like this. Okay, so now let's talk about the y-axis, the up and down axis. It's supposed to represent the frequency. Well, these hurricanes are happening, well, once, twice, 5 times, in that, or maybe 8 times, 10, right? So on and so forth. So you could do a couple things. You could go, 1, 2, 3, 4, 5, 6, up like that, or you could do, I'll just do 2, 4, 6, 8, 10, 12. And then I think that's all we're going to need. Yeah, on this one, actually, I don't even think we'll need 12. But that's okay. Now, also, you're going to have grid lines because you're doing this on graph paper, so it'll look a little more like this. All right, so there we go. So now we can just graph our data. I'm going to look at my table, okay? 6 to 8 weeks into the season, we had 2 hurricanes occur. So what I'm going to do is I'm going to go on my 6 to 8. I'm going to start my first column. It's going to look like that, okay? And actually, I'm going to erase that. I'm going to bring it over a little further because our bars are actually going to connect. So 9 to 11 had 1 hurricane happen, which is obviously between, 0 would be right there, 0 and 2. So he would be like that. And then I want you guys to take a second, just fill out the table, and then we'll be almost done. All right, so what's really cool about these histograms, when they look like this, is that we can visually see patterns, okay? And this is important because, what if we want to go to Florida? And we know, obviously, hurricanes happen, and so we kind of go, well, when should we go? And someone tells you, well, hurricane season starts on June 1st, and you're like, okay, that's true. But does that mean automatically that we shouldn't go on June 1st? Well, actually, no. Remember, June 1st would be, 0 weeks after June 1st would be June 1st, which would be like way over here. There's no hurricanes until 6 to 8 weeks recorded between 1997 and 2000. So even 6 weeks after June 1st, which would be approximately the middle of July, you're probably still okay because between 1997 and 2000, there's only 2 hurricanes that ever happened. Now, if you want to go, 15 to 17 weeks after June 1st. So like into, September, October. Man, you probably don't want to go because between 1997 and 2000, there were 10 hurricanes that occurred. So this histogram actually shows us the pattern visually so that we can make observations and we can analyze some data. All right, guys, that's all I have for you. Thanks for sticking with it. Look forward to seeing your notes in class and you as well. And I'll see you then.